If our planet were a storybook, its final chapter would be the inner core, a solid metal heart, forged under unimaginable pressure, older than the continents themselves, and pulsing with the physics that powers our magnetic shield. Today, let's journey to the very center of the Earth and uncover its secrets. Believe it or not, the inner core didn't exist when Earth first formed. In its early, fiery stages, the entire core was a sea of molten metal. But as our planet radiated heat into space and began to cool from the inside out, something incredible happened. Deep within, temperatures dropped below the freezing point of iron, even under those extreme pressures. About 1 to 1.5 billion years ago, the very center of our world began to crystallize. This was the birth of the inner core, and this process hasn't stopped. The inner core is still growing, expanding by about 1 millimeter every single year. As it solidifies, it releases latent heat and lighter elements into the liquid outer core. This release of energy is what fuels the geodynamo, the engine that generates Earth's magnetic field. So, in short, our planet's vital protective shield exists because the inner core is growing. Now, what is this inner core actually made of? It's often called the iron diamond of the planet. Despite being hotter than the surface of the sun, we are talking 5 to 6,000 degrees Celsius, it remains completely solid. The secret is the immense pressure, equivalent to 3.6 million times the pressure at sea level. This pressure is so intense that it forces the atoms into a solid state. Its composition is mainly iron, about 85 to 90%, with a dash of nickel and a few trace amounts of lighter elements like silicon, sulfur, or even carbon. But this isn't the iron you'd find on the surface. Under such crushing force, the iron atoms are packed into a unique crystalline structure. These crystals align in specific patterns, which is why seismic waves from earthquakes actually travel faster when they pass through the core along the north-south axis compared to the east-west axis. Here's where it gets even more fascinating. The inner core rotates, but it doesn't always spin at the same speed as the rest of the planet. Imagine a solid iron sphere floating in a vast ocean of molten metal, turning almost independently. Current science suggests that its rotation can speed up or slow down relative to the mantle and crust, possibly oscillating back and forth over decades. These subtle shifts in its rotation are thought to influence long-term changes in our magnetic field. It's a dynamic, ever-changing dance happening thousands of kilometers beneath our feet. So, why does any of this matter? Why should we care about a solid ball of iron deep within the Earth? Because this inner core is the engine room for life itself. Its growth, as we discussed, generates the magnetic field in tandem with the outer core. This field is our invisible shield, protecting us from harmful solar wind, which would otherwise strip away our atmosphere. It's what allows compasses and many migrating animals to navigate. Without the inner core, there would be no magnetic field, and life as we know it simply couldn't exist. Furthermore, the immense heat radiating from the core drives the slow, powerful currents in the mantle above. This process, called mantle convection, is the engine behind plate tectonics, driving the movement of continents, the building of mountains, and the eruptions of volcanoes. It powers the very geological heartbeat of our world. Finally, the inner core is like a geological time capsule. Its layers hold a record of Earth's thermal history, with its growth bands preserving a timeline stretching back 1 billion years. The crystalline textures and composition reveal clues about our planet's formation and the early behavior of its magnetic field. In summary, the inner core is a solid iron nickel sphere about the size of the moon, burning hotter than the sun, yet solid due to unimaginable pressure. It formed over 1 billion years ago and continues to grow, generating our magnetic shield, driving plate tectonics, and stabilizing the surface environment that we call home. It is, quite literally, the beating, metallic heart of our living planet. Thanks for joining this deep dive into the Earth. If you found this journey as fascinating as I did, be sure to like, subscribe, and follow for more explorations into the wonders of our universe.